Evening 12. Today we're going to discuss ANOVA. ANOVA is nothing but analysis of variance. So, if more than 2 means, we can calculate a method for analysis of variance. So, it is a powerful statistical technique used to compare the means of more than two groups, unlike t-test, which are limited to comparing means of two groups. So, ANOVA allows us for studying at the simultaneous comparison for multiple group means, making it a good tool. We'll discuss with an example for ANOVA now. So here we go. A plant biologist wants to compare the average height of three different varieties of sunflower plants, variety X1, variety X2, variety X3, grown under the same condition, and they are randomly selected 5 plants from each variety and measure their height after certain period of growth. So here we have X1, X2 and X3. So in X1 variety we have 3 plants, and X2 variety 3 plants, and in X3 variety 3 plants. So we'll discuss this calculation by each steps. So before this we need to frame h naught, or for this says that there is no significant difference between three different varieties of three plants from each variety. So that H naught says that there is no significant difference between the three different varieties of three plants from each variety. So after writing this H naught, the next step is we need to calculate here as after adding these all, we'll get summation of x1, summation of x2, summation of x3, and n values also. So this will considered as n1, n2 and n3. So after adding this x1, we'll get x1 as 9 and n1, 2, 3. There are 3 observations. So similarly, n2 is also 3 observations, n3 also 3 observations. So after adding this, we'll get around 12, and this is going to be 15. So our next step is summation of total x's. So summation of all x's, which is nothing but summation of x1 plus summation of x2 plus summation of x3. So we have 9 plus 12 plus 15. So adding all this will get around 36, and capital N. So the totally number of observations 3 plus 3 plus 3. So we have totally 9 observations. So by doing this step, this is the basic one, and after this we'll do this calculation step by step. So first step here is calculating the total summation of all group observations. We need to calculate, so which we already has calculated, and that is here. So all we have submitted, then we have got that as 36. So ex is equal to 36, and all total observations is equal to 9. And next, this also we need to write. Summation of x1 is 9, summation of x2 is 12, and summation of x3 is 15. Similarly, n1 as 3, n2 again 3, n3 it's going to be 3 again. So step 2, what we do? Calculate sum square, or else total sum square of all observations. So we'll give it as TSS, which is nothing but total sum square. So total sum square of all observations, which is nothing but our first observation is 2 square, 3 plus 3 square plus 4 square, again plus 3 square. Like this only we have to write down all those values here. So we need to add all those sum square values, as firstly we have 2 square plus 3 square plus 4 square plus 3 square plus 4 square plus 5 square plus 4 square plus 5 square plus 6 square. So TSS, total sum square, is equal to 4 plus 9 plus 16 plus 9 plus 16 plus 25 plus 16 plus 25 plus 36. So we need to add all these values again. So we'll get summation of x square, or total sum, sorry, x square, not, this is not total sum square, this is summation of x square, is equal to 156. So the third step we are going to do is, third step here we are going to do is calculating total sum square, that is TSS, by using formula. So the formula we have is total sum square is equal to summation of x square minus summation of x and divided by capital N whole square. sorry, this is square to this one only. So this is our formula. So we'll put values in this. So however, we know that summation of x square value as 156 minus we have summation of x as 36. So summation of x 36 whole square divided by 9. So after simplifying this, we'll get 156 minus 144, and which is equal to 12. So total sum square is equal to 12. So next step we need to calculate is next is SSB, which is nothing but sum of square between groups. So we have a formula for sum square between the groups is summation of x1 whole square divided by n1 plus summation of x2 square divided by n2 plus summation of x3 square divided by n3 and minus summation of x square divided by capital N. So in this we need to put our values. So what are values? Here I kept as x1 value, x2 and x3. So we have to add these value in this formula, and after we need to simplify. So what value will get? That is nothing but our sum square between. So sum square between the groups is equal to firstly x1 square, summation of x1 value we have 9, so divided by 3, n1 as. Similarly 12 square divided by 3. Similarly 15 square divided by 3 minus 36 square divided by 9. According to formula we kept the values. Then we need to simplify this. So 81 divided by 3 plus 144 divided by 3 plus 225 divided by 3 minus 1296 divided by 9. So, and again we need to simplify this. We'll get 27 plus 48 plus 75 minus 144 is, after subtracting and all, we'll get the main value of sum square of between the groups is 6. So next, fifth step is nothing but calculate the sum of square between within the group. So we'll sum square within the group, sum of square within the group. So for this again we have a formula. Sum square within the group is equal to total sum square minus sum square between the groups. So already we have total sum square as 12 and sum square between the group as 6. 12 minus 6. So 12 minus 6 is equal to 6. So sum square within the group is 6. So our sixth step is calculating degree of freedom between the group and within the group. So between the group we have number of group minus 1. So how many groups we have? We have totally 3 varieties, means 3 groups. 3 group minus 1 is equal to 2. So next we need to calculate the degree of freedom within the group. So how many groups we were having? So formula is number of observation minus number of groups. So totally 9 observation we are having and 3 groups we are having. So 9 minus 3 is 6. So this is degree of freedom between the group PG, and this is degree of freedom within the group WG. So next, 7th step, calculating 7th step, mean of sum square. Again this is for within the group and between the group. So here we have mean of sum square between the group is equal to sum square between the group divided by degree of freedom between the groups, and mean sum square within the group is equal to sum square within the group divided by degree of freedom within the group, WG, within the group. You can write it in the capital form also, so it will be very easy, within the group or between the group and within the group. So mean of sum square between the group, we were having sum square value as 6 and degree of freedom as 2. After dividing this, we'll get around the value as 3, which is nothing but our mean of sum square between the group, and same mean of sum square within the group, which is nothing but, so sum square value we have as we took that as 6, and divided by degree of freedom we have got it as 6 itself. So 6 divided by 6 will get around. So our 8th step is calculating F ratio. 8th step is calculate F ratio or F statistic. So F ratio is equal to mean of sum square between the group divided by mean of sum square within the group. So between the group we have 3 and divided by 1, so which is nothing but 3, or else we used to call it as in the form of ratio 3:1. F ratio is 3:1. F ratio is equal to 3:1. So next what we have to do is we need to frame an inference for this. So inference says that, so according to degree of freedom and at the level of significance, so the calculated table value will get around as so we need to know that when the calculated value or F ratio value is less than the table value or critical value, then H0 is accepted, or else, so our F ratio is calculated value is we were having as 3. So at the significance of 0.05 and at the degree of freedom of 6, and it's 6 degree of freedom within the group is 2 and between the group is 2 and within the group is 6. According to that we'll get the calculated value at this level of 0.05 significance, we'll get around the 5.14. So which is more than the calculated value. So F ratio, critical value more than the table value, calculated value more than the calculated value, or else F ratio. In this condition H0 is accepted. Similarly, if the critical value is less than the calculated value, then H0 is rejected. H alpha or H alternative need to be framed. If any doubt, please comment it in the